Ama basitten de ortayla. So, hello everyone, a very good evening. Yeah, still listening echo. Hello. Hello. Is it audible?
Yes, sir.
Okay. I don't know what happened here, but yeah. Okay, let me start. It's audible right now, right? Um, so what I was saying is that we have this XY pair, right? And what we do is that we train a model F with X as input and theta or W as parameter, and we get some Y. And finally we aim to find the optimal set of W, but we can end up in different set of W instead of the optimal set of parameters. So let's say I name them as hypothesis 1, 2 up to hypothesis n. Hypothesis 1 is correspond to the weight we found initially, then we changed it, and similarly we have n hypothesis. So the generalization error says that the probability of the hypothesis n hypothesis I, the probability of the probability of an hypothesis I making minimum error. That is the generalization error. So generalization error says that an hypothesis, the probability of an hypothesis making an error should be minimum to make the generalization error minimum. If it is higher, we can say the generalization error is higher. On the other hand, the empirical error is something like the mean of the I equals to 1 to m, the mean of all the errors should be minimized. So all the samples should be minimized. So it's like it's an identity function hi x j not equals to h. This is the empirical error. So if you see, empirical error is mostly is something you can say that empirically we can calculate, and generalization error is more probabilistic. If you see the statements here, statement 1 says that empirical error is always greater than the generalization error. And second is training data and test data have different underlying true distribution. Okay, so here we can say that x and y sample from distribution D. The second statement says that training and test data have different underlying true distributions. Um, Based on this, choose the correct option. So yeah, so I'll just discuss the answer. Yeah, so the thing is that the empirical error can be greater than or less than the generalization error. So generalization error is something that we are expecting it to be lower for all the samples, and the empirical error is just the mean of all the error for the data points. The empirical error can be greater than or the less than the generalization error. Hence, the statement 1 is false. And the statement 2 says the training data and test data have different underlying true distribution. This is also wrong because we assume that the train data and test data are from the same distribution. That's why what you do is that that's why we train the true distribution. Uh, uh, we assume that the training data and testing data have same distribution. This might be a bit little bit different, but it is not completely different distribution. If it is from completely different distribution, then training on the training data will not give us a better model for the test data as well. Hence, statement true is also such as statement two is also false. So option D will be correct. Both statements are false. I'll copy paste some more of the questions in the set. Give me a moment. Yeah, so this is the second question. It's a calculation based question. It will not take much more time. Third question. Okay. So let's solve the second question. 0.969. Let's see. Uh, yeah, so the union bound, as you know, in probability is that probability of union of I equals to 1 to 5 AI should be less than or equals to probability of A1, or I can write it like this. Summation of I equals to 1 to 5 probability of I, right? So this is a union bound, or you can just expand it by writing P of AI, P of A1, P of A2, P of A3, P of A4, and P of A5. Okay. So probability of AI is 2 to the power I minus I. So that is less than equals to probability of A1 would be 2 to the power minus 1 plus 2 to the power minus 2 plus 2 to the power minus 3 plus 2 to the power minus 4 plus 2 to the power sorry, plus 2 to the power minus 5 less than equals to, this is 0 0.5, 0 0.25, 0 0.125 plus 1 by 16 is 0 0.06 2, 5 plus 1 by 2, 1 by 32 is 0. 0.0 103 40 1 80 2 then 5. Okay, and if you add all these things, it will come to 0. Let me add it outside. It's 0.96875 equal to 0.969. So option C is the correct answer. Okay. Moving on to the third question. Which of the following is at the shortcomings of TD learning that Q learning resolves? TD learning is the temporal difference learning. Okay. So I think someone gave the correct answer, Bharti. I'll briefly explain what is Q learning and what is a TD learning, to be honest, and how it is better than the Q learning. Yeah. So what happens is that in a reinforcement learning setting, what happens is that there exists an environment and there exists an agent. So it's like the robot sort of thing. So let's say this is an environment and this is an agent. The way the agent interacts with the environment and move along the environment is called the reinforcement learning, and we're training the agent to move in the environment while maximizing its reward, this current reward as well as future reward. So you'll say like, what is reward, right? So each time the agent is at a place, it's called the state. State 1, state 2. The agent reaches from state 1 to state 2 by taking an action, say A. Okay. And the reason it took the action A to reach the state 2, S2, is that
the reward at H2 should be more than S1. Or in other words, the reward at S2, so the reward at S2 might not be more than S1, but if it follows this path, it goes to S2, initially there might not be a good reward, but effectively in future the expected reward should be maximum, right? So this is basically the reinforcement learning, where we given given an agent is sitting on a state S. The reinforcement learning teaches us to take a step, so to take an action A to reach to a new state S2, such that the expected reward is maximized. That means the reward that it will get by going to S2 now might not matter, but in future, this move might bring me more reward or might help in favor of me. So this is the reinforcement learning setting. Okay. So what TD learning does is that this is state S1, S2, S3 up to Sn. Okay. So what happens is that in TD learning, so it will go to S2. So it will take an action to go to S2. Okay. So from S2, there can be S3, there can be, let's say, S3, 1, S3, 2, and there can be other states as well, like this. So the state from S2 it will take is difficult, right? Because it was just one step. There might be either state here as well, right? So what will happen is that this agent will take a step by taking an action, then it will reach there. Then it will see all the options here. Okay. Based on the options here, it will come back and edit the step and go to another state. Then it will see the options here. Then it will go to another state and it will see the options here. So similarly, when it reaches here to see the options, then it will come back and state another state like this. So what happens in the TD learning is that it actually go to the future and see if it took this step, what is the reward that it is getting in the future. Based on the reward, it comes back to the previous state and corrects the action, right? So it's like you're playing and you're playing chess and you took a move and your friend actually can kill the king or something like that. So what you do is that, okay, you said, okay, I'll retract back to the original state and try playing again the move. Then you play a different move. So it is the TD learning or the temporal difference learning. So, but what Q learning does is that, so let's say you are training an agent using the Q learning. So what Q learning will give you that Q learning, let's say Q learning is an algorithm. Given a state, given the state and the agent, it will give you the state action pair. I mean, the action you will take and the state you will reach, it will give. The algorithm will directly give you. So after the training, you can directly go to this, follow this path and you reach the optimal state, but which is not true for the TD learning. Okay. So if you see the options, which of the following is at the shortcomings of TD learning that Q learning results? The TD learning cannot provide values for state action pairs, limiting the ability to extract an optimal policy directly is true because, as I just said, it do not provide state action pair. Second option, TD learning requires knowledge of the reward and transition function, which is not always available. So as I said, it has to go to the future and check if it is feasible. Then I have to come back and correct the step, right? This might not be feasible in all scenarios. Let's say you are training and reinforcement learning agent to trade for you. You don't know that, like, after you place a trade, you cannot come back and say, okay, I will not place that trade, I'll play something else. If you place a trade in an exchange, it will be executed and you will get your shares and you'll the money will be deducted. You cannot just come back and you know try to place the trade again. So there is no point in coming back. It's an irreversible process. That's why TD learning requires the knowledge of the reward and the transition function, which is not always available, is true. Okay. Then third is TD learning is computationally expensive and slow compared to Q learning is not true, because Q learning is also computationally very expensive. Um, if we are talking about the computational complexity of the algorithm. Then fourth is TD learning suffers from high variance um, in value estimation, leading to unstable learning. Is true, because as you have seen here, that a lot of things varies when you change a action. So you go there, there's a lot of variance. So you go there, you see if it is feasible or not. You come back and change the action again. There's a lot of variance. And final option is TD learning cannot handle environment with continuous student action space effectively. It is false, because it can actually handle continuous space. Okay, so that's more or less about the TD learning and the Q learning setup. What happens is that now we have deep Q learning. So deep Q learning. Deep Q learning is basically when you are using a deep neural network to decide the state action pair. It is just deep Q learning. And there are several other type of reinforcement learning where the state and action is continuous, or state and action is one continuous, one discrete, or the environment is not fully observable. It is partially observable. You cannot know the environment beforehand. It is changing. It's like, let's say there is a flood and you have a robot that is going to rescue people. So the environment drastically changes each time, because you are in the flood. Okay, so a lot of things. There are a lot of scenario where the environment is not fixed; it is keep on changing. So a lot of type of reinforcement learning has been introduced recently, but these are the basic ones, like the TD1, the Q learning. Okay, next question is just directly formula based question. You try to solve this. Question number 4: given 100 hypothesis function, each trained with integral examples, what is the lower bound on the probability that does not exist a hypothesis function with error rate greater than 0.1? Sir, shall I ask? Okay, yeah, I can ask.
Sir, sorry to interrupt.
Yeah, no worries.
Yeah, this is one of the faculty. Actually, problems we are having a lot of NAC and NBA. So earlier 1 or 2 sessions, live sessions I have attended. Okay, in between I had missed this. Can we have the YouTube links for this?
Okay, I've given.
Because now, sir, first in the first sessions, I had joined, one drive link they have provided. I think every session will be handled by the same person or some other person. Okay. So all the live sessions, discussions is available on this YouTube?
No. So there are 3 tutors actually.
Pardon?
So there are 3 tutors,
Huh?
three people taking the live session.
Okay.
So I'm sharing this Excel sheet.
Huh?
This Excel sheet actually is linked to give you the link for all the tutorial sessions taken by all 3 tutors.
Okay. In the Excel sheet, they are giving the YouTube links or what?
Yeah. You can check. I pinged in the chat, Teams chat.
Yeah.
You can,
I have seen. I'll check it, sir. I'll check it.
yeah,
Sir,
they
it is.
can go to
Yeah, sir. That's
any.
why. Yeah. Sir, one thing, the exam is scheduled on this, no? What next week, right?
Yeah.
Next week only, na?
The thing is that I'm not sure about the exam dates. You check the announcement actually. I don't
Oh,
have access to the announcements actually. You check the announcement. If you do not, if you have any doubt regarding the administrative part, like when the exam will happen or what is the format of this, you can ask the NPTEL help desk mail.
Okay,
They'll
okay,
reply. Yeah.
okay. Chalo.
Okay. Yeah. Someone responded 27.
27 it is there, but still
Oh,
we
okay.
will.
The date. Okay, I thought the answer. The answer option is different. Hmm.
Yes, sir, continue.
Okay. Yeah. So I try to solve this question.
Right.
Okay. Pretty straightforward. If you know the solution. Yeah. So the solution to this question stems from this formula that you might have seen in the lecture that says that the probability of the probability that there do not exist an hypothesis HI such that the generalization error on HI and the empirical error on HI, the difference between the generalization error and the empirical error is greater than 0.1. The probability of not existing an hypothesis such that the difference between the modular difference between the generalization error and the empirical error is greater than 0.1 is greater than or equals to 1 minus 1 minus 2 into k into e to the power minus 2 into gamma into m. It's a very big formula. Just remember this. M is the number of samples. Okay. And k is the number of hypotheses. K is the number of hypotheses. And what? This gamma is error factor, right? So I can put gamma here. The error factor. The reason we're putting 2 because it is modular. That is, it can be greater than gamma or less than gamma because we're putting modular, we're multiplying it by 2. This is just a formula for which dimension. So if we apply the values here, it will comes out to be the probability of there not existing any HI such that the difference between the generalization error and the empirical error greater than 0.1, so is greater than equals to 1 into 2, sorry, equals to 1 minus 2 into k is 100, so just write me down, k equals to 100 because we have 100 hypotheses, each 10 to the power 6 samples, so m equals to 10 to the power 6. And error rate gamma equals to 0.1. Okay. So 2 into 100 times e to the power minus 2 into 0.1 into m is 10 to the power 6. Okay. So this is greater than equals to 1 minus 200 e to the power minus 2 into 0.1 into 10 to the power 6 is 10 to the power 5, right? Sorry. So this is square here. So this is square here. So this will be, no, not square, sorry. Is square here? Yeah, square there. So if it is square there, so this will be square here, and this will be 10 to the power 4, I guess. 4, okay. So A, option A is the correct answer. Let me check the solution before time. Option A is the correct answer. Yes, this is the correct answer. Okay. Have a look at this. Just a calculation problem, not much. Okay. And yeah, we'll go to the next question. This is a comparison based question.
ఇస్రాయేల్ యుద్ధాన్ని జ్ఞాపకం చేసుకున్నాయ్యా ఈ రాగడ సమయం దగ్గరికి వెళ్ళిపోయిందయ్యా నీవు చెప్పిన మాటలు నెరవేరుతున్నావు విగ్రహాల కోసం చేరైతే విగ్రహాల డబ్బు చేరుతానని ఎంతలో రాయిపోతామయ్యా.
Sorry. Not mine actually. So read the comprehension. I'll solve the question based on this comprehension. Yeah, so this is the comprehension. Read this and we'll solve the question based on that.
That's why then when Sochaki rather than it be much better to focus on the solving problems part than that MCQ part, because else मुझे भी ऐसे ही create करने पड़ते कुछ question.
Okay. So this question is based on the reinforcement learning, and so as I said earlier in the lecture, how the reinforcement learning works by choosing the next step. Where is it? Yeah, choosing the next step based on the action that maximizes the future reward. So I'll show you the situation. So this is a simplistic game, and we'll see how the reinforcement learning agent can learn this to play this game optimally. So we have a start state here. Okay. We have a start state here. The agent start at the start state, and it can choose to move left or move right at each turn. Okay. If it reaches the right end, there is a +1 win. If it reaches the left end, there is a -1 that loses, right? So instead of saying that where the agent is winning or losing, we say it got a reward of +1. Or if it is at the left end, we say it reached a it sort of got a punishment of -1. Okay. So the objective of the agent is simply to maximize the reward it obtains. So it will maximize the reward that it is obtaining, right? For each state, we define a variable that will store its value. Okay, the value of the state will help the agent determine how to behave later. Okay, so based on the value, it will choose the next step. If the next step is like leading it to win, it will be take that step. Or if it is not, it will not take that step. Okay. First, we'll learn the value. So each state is a each state has a value, right? So the leftmost has a value of -1 and the rightmost has the value of +1. All the other intermediate state, including the start state, has a value of 0. Okay. So the states has a set, right? The states has a set x1, x2, x3, x4 and start with SL being the state to its immediate left and S right being the step to the immediate right. Okay. So we have a state and we have a functional state SL and SR. If I am at x3, my SL would be start and my SR would be x4. If I am at start, my XL would be x2 and my XR would be x3. So these are the sets that can that the agent can stay. Okay. A value of a state S, they are the initial value. Okay. But a value of a state S, Vs, is defined by this equation where we're saying that 0.9 into the maximum value of the previous state and the maximum value between the left state and the right state. So what will be the value? So this is the formula. So from which we are getting the value of the left state as the value of the state. Okay. So the value, what is V x4 after one application of this formula. So the value of a state is defined, it is determined by this and it is changing. Okay. So value of x4, as you can see from the equation, it is 0.9 times max of value of SL. SL is x3 and value of SR, that is the right one, is RE, right? If you calculate this, it will be 0.9 times maximum of value of x3 is 0, value of RE is +1. So out of 0 and +1, it is +1 is the maximum. Hence, the value comes out to be 0.9. Value of x4 becomes 0.9, right? Okay. Similarly, try to solve this. Similarly, try to solve this one. Question number 7. What is Vx1 after one application of this formula? For a reference, Vx1, Yeah, so you have to find Vx1. So Vx1 is here. Vx1. Try to solve this. I'll give you 2 minutes. Answers, no? Yeah, I'll solve it. So after one application of this given formula, you'll for x1 you'll get something like if you see x1, the left is -1 and right is 0. So the Vx1 would be 0.9 times max of B LE Vx1. This is -1. This is 0. Maximum is 0. So 0.9 times 0 equals to 0. Okay. Fair enough. Then what is Vx1 after V converges? So after V has converged, so we'll see how V has converged. When the V converges, so V x4 as we know. So what is V converge means we have the value for all the states, updated value. So as we know, V x4 is equal to 0.9. Okay. So if I calculate V x3 at this point, what it will be? So V x3 will be equals to 0.9 times V. So Vx3 is maximum of VSL and VSL. Left is start, right is x4. So it is start and V x4. That is equals to 0.9 times. The start is 0. Sorry, this is max. And Vx4 is 0.9, right? So 0.9 times 0.9 equals to 0.81. So x3 will be 0.81. Okay. So similarly, V start would be 0.9 into max of start is x2 and x3, right? So Vx2, Vx3 go to 0.9 times max of x2 is 0 and x3 is 0.81. That is 0.9 into 0.81 equals to 0.729. Okay. Similarly, if you calculate V2, it will similarly if you calculate Vx2, it will come out to be 0.9 10 to the power 4, and similarly Vx1 would be 0.9 to the power 5, which will be equal to 0.54 and 0. So you see the pattern, right? So as we are going in this direction, we are getting multiplied by 0.9, 0.9, 0.9, 0.9, 0.9. So x1 would be 0.54. That A is the answer. Is the optimal value. Okay. In this way, you can solve this question. Okay. Yeah. So I guess this concludes this week's questions. 8 questions for this week. You can try solving other practice questions as well regarding the reinforcement learning and the VC dimension and all these things. And if you have any doubt, you can ask in the announcement section, so I'll answer. Yeah, so this ends today's session. I'll see you next week. Not next week. So yeah, so this was the, I think, yeah, so this was the last, this is the last week's lecture, and we have an extra session tomorrow where you can ask the doubts and everything. So okay, so I will see you tomorrow for 1 hour. There's a doubt clearing session. Until then, bye bye. I'll upload this session to the YouTube as well. Bye. Thank you.